Hello everyone, welcome to our first weekly progress video for the course semester project of object-oriented programming and design methodologies. This is Amali Jaffrey and my group members are Mohammad Kamal Raza and Zaryana Siddiqui. Actually, we are working on a game called Mckinsey game, as you would be aware of it from our proposal already submitted and which got accepted. So basically, let me explain a little bit about the game itself. This is a turn-based game. In this game, actually, the player is presented with a tile map with different obstacles and terrain features, and a plant in the middle. Animals will randomly spawn at arbitrary corners of the map and move towards the plant on every turn. The player has a disposal of creatures and obstacles that they can be used to prevent the animals from eating the plant. The player can only make moves for the first 15 turns, and after that the animals keep spawning and eventually eat the plant. Therefore, the player cannot win in this game, but that is not the objective of the game either. The objective of the game is to keep the plant safe for as many turns as possible using our initial setup in the first 15 turns. The more turns a player is able to keep the plant alive, the more chances he has of passing the test. So basically, one of the progress over the last week was to find the sprite files for our corresponding assets. Since we have chosen, like, there will be predators or creatures which will act as a protector, and there will be obstacles that will be placed by the player itself, and there will be randomly spawned attackers. So we have chosen 3 attackers that will be randomly generated. The 3 attackers are snake, wolf, and fox, while the 3 protector animals are lion, eagle, and a plant zombie. While the 3 obstacles we have chosen is in a mountain, a pond, and a bush. So basically, over the last week we have found the corresponding sprite files for these assets. So, like for the obstacles, the mountain sprite file is over this one. The bush sprite file is like this one, and the pond sprite file is this. Then coming to protectors, the first protector lion, this sprite file for lion, this is the sprite file for eagle, and this is the sprite file for plant zombie. And other than this, the sprite files for the attackers are these. This is a sprite file for fox, which will be an attacker, sprite file for wolf, which is also an attacker, and the sprite file. Other than this progress, one of the major challenges that we encountered over the week is to develop dynamic changing screen, like the transition from start screen to play screen and towards the end screen. Kama will be talking about this towards the end of the video, while now I want Zaryan to explain this table that we have developed regarding the classes that will be implemented tentatively with their attributes, functions, and what is the relationship between these classes.
Last week we began our work by working on defining our classes and the various relationships between them. After this we came up with the tentative classes which may change as the project work progresses. Firstly, the game class is used to manage the game loop, handle events, and render graphics using the SDL library. It provides functions for initializing, rendering, handling events, and quitting the game. Moving on, the game object class is the base class for creating the objects for the game. From this class, we derive multiple child classes such as attacker, protector, and obstacles. It has the attributes and functions as shown in the table. The attacker class is the child class of game object, and from this the attacking animals will be inherited. Likewise, the protecting animals will be inherited from the protector class. Therefore, the attacking and protecting animals are grandchildren of game object class. The protector class is an abstract class since the attack function is a pure virtual function because every attacking animal derived from it will have a different attacking method. Moving on, there are 3 attacking animals and protecting animals classes, which are snake, fox, wolf, plant zombie, eagle, and lion respectively. They have a region type attribute which tells that in which environment they perform the best. For example, snake has max speed in the bushes. Lastly, there are obstacle classes, mountain, pond, bush, which are derived from the obstacle class.
So this is the game that we have currently made. This is our start state and it displays this image, and when I hover over any button it changes its color. So we have a highlighting system, and when I click on the start game button it will transition to the play state, and this is our play state. So for we have this grid of grass tiles, and the tiles are highlighted based on the position of the mouse cursor. So the plan is to randomly spawn enemies from these corners. So this is the area where the beyond this we cannot see anything, and the animals will come from these areas into the visible area and then move towards the plant, and their end goal is to eat the plant. Our goal is to protect it, and we will place protectors throughout the grid to slow down the enemies. So after we lose, we will transition to the game over state. So right now we have no gameplay mechanics, so we have just assigned a key to transition to the game over state, and by pressing the key we go to this state. We will add buttons to go back to the start screen in the game over screen. So that is all the game that we have made thus far.
Now a bit about the code.
So let's start with the main class of our game, the game class. This class is responsible for handling the initialization and drawing routines of STL library, and this class closely resembles the game class that we have seen in our homeworks, but we have made a few changes. Specifically, we have enabled vertical synchronization so that our game does not use more computer resources than it needs to display 60 frames per second. And we have added alpha blending so that we can decrease the opacity of objects drawn through the draw functions of STL, and this functionality is used in our play state to highlight grass tiles. Next, the play function in this class creates the main loop of the game and handles the events and drawing functions. Next up we have our Mckinsey game class that ties all of the other classes together, and this is used to decide whether which state that we currently want to display and all of the texture loading and stuff. So speaking of textures, we have made a texture manager class to initialize the STL image library and load textures and store textures using standard map library of C++. This enables us to store many textures without the need for creating multiple texture pointers in our main class. Next up we have the state classes that we use to transition between the different screens of the game, the play screen, the start screen and the game over screen. So the way it works is that we keep track of a state variable, and depending on player input we change the state variable, which in turn decides which state functions that we want to call. So the state classes are implemented individually right now, but we plan to create a main class for these and inherit all of the state classes from that class so that we can encapsulate the similar code of these classes into a base class. So currently we have three state classes: the play state, the game over state, and the start state class. The start state class displays a still image of the starting screen, and it handles the highlighting of buttons and the clicking of buttons to start the game. Next up we have the play state, which handles all of the main logic of the game, and this is where we will implement all of our game's core functionality. And so far we have made a tile mapped grid of grass tiles, and we have added the functionality to highlight grass tiles based on our mouse coordinates, and we have displayed the plant in the center of the screen for now, but as we move on we will add many other entities to the play state, and the plant would be randomly generated in the center area of the screen. Then we have the game object class. This is the base class that will be inherited by all of the objects in a game. So far we have inherited the plant class from this class. So the game object class in this way helps us encapsulate all of the core functionalities that all objects of our game will have, so that we do not repeat the code over and over again in all of the different entities that we create in our game. So that is all that we have done so far, and over the next week we plan to add the generation of protectors and enemies onto the screen, and then we will implement a pathfinding algorithm that will help the enemies find the shortest path to the plant, and we will move on to adding the other functionalities of the game from there. Thank you.
Also, sorry for all the bird noises throughout the video. They were very eager to eat my plants, so I had to hide in a corner of my room to record this video.